Okay, so I want to just talk a little bit about what we did yesterday, which was the volume by slicing and the volume by disc. And the problem that I want to work on, the base is going to be this region right here. So if I take and I draw an axis, uh-oh, that ain't what I want to do. I want this to move back. Okay, that's good enough. All right. So this is the X and Y axis here. And the region that I have graphed is f of x is equal to the square root of x e to the minus x squared. So this is the region. All right. So the first problem is to find, so it's between x equals 0 and x equals 2. So I graphed this for you. All right, so the first question is going to be, so this is example 1, find the volume of the solid if the region above is the base and the cross sectional areas perpendicular to the x-axis are squares. Okay, so this is what we have. All right, so this is our first problem. All right, so perpendicular to the x-axis are squares. All right, so the question is, how do we do this? So that means that if I were to do this so basically it looks, it's kind of hard to draw because it's a cute little function there. But if I were to draw it in 3 space over here, then I have this function that looks like this. So that is my region. And then their cross sections are squares. So standing up outside of this thing are squares. Okay. So there's my square. So the base is that really cute curvy thing. So that's the base. That's what is holding the paperweight. So think of this as a paperweight, and that base is that nice smooth curve. But everything standing up out of it are squares. Okay, so these things are squares coming out of it. So I've drawn the picture. So that was number 1. So number 2, I need to find the limits of integration. So what are the limits of integration?
0 and 2.
Good, from 0 to 2. So the limits of integration are from 0 to 2. Then I need to identify my cross-sectional areas. So my cross-sectional areas are squares. So I need to find the area of the squares. So the area of the squares well, that's equal to x squared Well, let's just say it is L squared, where L is the length of one side. Okay, so now I need to find it for this particular problem. So for this particular problem, if you remember, we have squares that are standing up outside of it. So if I can draw this, so I can pick any X. So here's X. And you have to think of this thing as if it's standing out the page. That's why I drew it like that. So it's standing out the page. And so therefore, one side of this, here's the one side. So the one side of this is, that looks crazy. Let me just do it with a regular square. Okay, so you got to think that square is standing up in the air. Okay, so the length of one side of the square, what's the length of one side of the square? Can anybody tell me? So here's a given X, here's 0, and here's 2. So between 0 and 2, I chose 1X. And based on that X, I need to find the area of the square. So what is the length of one side? And remember, this side over here is the side that's on the bottom is sticking, everything's sticking up in the air. So what is the length of one side? Nobody knows? Okay, this curve that is nicely graphed here is the curve y is equal to the square root of x times e to the negative x squared. So for any x, this is its height, f of x. So for any height, any x, that's its height. So that means that this distance is y. So the length of one side, so in number 5, we're trying to find the area. The length of one side of the square is the square root of x times e to the negative x squared. Okay. Then the area is that squared. So that's going to be the square root of x times e to the negative x squared. And what does that simplify to? What does that simplify to? That's this squared. Are you guys there? Sometimes I feel like I'm talking to myself. Hello. Y'all gonna make me do this whole problem all by my lonesome. All right, so that becomes the square root of x squared times e to the negative x squared squared. So this is going to be x e to the negative 2x squared. Okay, so now I have a formula. Yes. Thank you very much. And Caesar, there is, so let me tell you, when you multiply, when you have an exponent to an exponent, you multiply them. So the 2 gets multiplied by the negative x squared and gives me negative 2x squared. I appreciate you taking the time to simplify it for me. Okay. All righty. Okay, so a of x simply becomes x e to the negative 2x squared. All right, so therefore our formula number 6, volume, is the integral from a to b of a of x dx. So this is the integral from 0 to 2 of x e to the negative 2x squared dx. And to solve this problem, I'm going to let u equal to negative 2x squared. Okay. I'm going to let du equal negative 4x dx. So I can see from my problem that x dx is negative 4, whoa, is negative du over 4. We also now see that if u is 0, if x is 0, u is negative, is also 0. And if x is 2, u is negative 8. Okay, so that is negative 2 squared. And I'm sorry, 2 squared times negative 2. So my volume becomes the integral when x is 0, u is 0. And when x is 2, u is negative 8. X dx becomes negative 1 over 4 du. And so e to the minus u. So that's just e to the u, because that whole thing is u. This whole thing is u. So I have e to the u, and then I have negative 1 over 4 du. So that's going to be negative 1 over 4 e to the u, evaluated between 0 and negative 8. So that's negative 1 over 4 e to the negative 8 minus 1. So this is 1/4 1 minus e to the negative 8. Okay, that's it. That's the volume. All done. Okay, any questions about that?
I have a question.
Yes.
Why did you drop your sign?
Drop what sign?
Negative 1/4.
Oh, because you mean at the very end here?
Mm-hmm.
I multiplied the negative through, so notice I made it negative 1/4 times negative 1 gives me the positive 1, and negative 1/4. So I just pushed the negative through.
Okay.
Do you see it now?
No.
Okay. I had a negative here, right? That negative times 1/4 e to the negative 8 gives me this term. And that negative 1/4 times negative 1 gives me this term. So I just distributed the negative.
Okay.
You don't have to do that though, right?
No, you don't. I just like to do that because I inherently know that e to the minus 8 is a very small number. So if I subtract it, 1 from it, this is going to be negative. So I just made it so that it looked positive, even though you can leave it like this. Both answers are fine.
I have a question real quick.
Yes.
How did you get x equals 2 and u to the negative 8 again?
Okay, so here, when x is 0, you have to plug it into u. So you get u is equal to negative 2 times 0 squared. When x is 2, that's the top limit. So when x is 2, you have to plug that also into here.
Okay, that's it. Thank you.
You're welcome. Okay, anybody else? Any other questions? Okay. All right, we're going to take the same region now and we're going to revolve it about the x-axis. All right, and we're going to get a different kind of solid. All right, so the second problem. All right, it's going to read as such. So here's example 2. Consider the region bounded by the curve f of x above and the lines y equals 0. Come on now. Why are you acting crazy? And x equals 2. Okay. What is the volume of the solid generated by revolving the region about the y-axis? Okay. All right, so we're going to take that same region above. Okay, I'm gonna make it just a wee bit smaller. Okay, so we're going to take the same region above and we're going to revolve it about the x-axis. Okay. So here we have the region. And we want to revolve it around the x-axis. So when I revolve it around the x-axis, it's going to come down here like this. Like that, as best as I can make it. Maybe it's got a little steeper. That's not bad. Okay, so that means when I pick any x, here's my x. When I revolve this thing, I'm going to get a disk, as you can see. There's my disk. Okay, so when I revolve this thing about the x-axis, I get the disk. So as you can see, this is my area. So my area for the disk method is pi times the region squared. So my area is always pi times the radius squared. Now, in this problem, here's my radius. My radius, again, is the height of the function. So here's my radius, which is some y, and this is y is equal to the square root of x, e to the negative x squared. Okay. So my radius, r, is equal to the square root of x to the negative.
There's a longer version too. I know, I can see it.
So therefore my volume, which is the integral from a to b of pi r squared,
The mobile game.
is equal to the integral from 0 to 2
Mobile game is
of pi r of x squared is x e to the negative 2x squared. So that is pi times the integral from 0 to 2 of x e to the negative 2x squared. Didn't we just compute that? Dx. Yes, we did. That was the one reason I chose to do this problem. So this answer is just pi over 4 times 1 minus e to the negative 8. Because we already computed the integral, so why? So I picked something where we wouldn't have to do a second integral. Okay, so we revolved it around the x-axis. And so, did I say y-axis? Oh, that's bad. Ooh, we ain't learned that one yet. We need the x-axis. We didn't learn how to revolve it around the y-axis yet. That's something altogether different. Okay. Yes. Okay, now we got it. Okay, so we did a volume by slicing where we put squares and stacked it. This one kind of looks like, oh, I don't know. If you turn it on its side, it may look like a Weeble. I don't know what it looks like. An onion? No. But it's got a big bulb and then it goes to a point. And it's three-dimensional because we took the whole filled-in region. So this whole region in the second part of the problem, the whole region is filled in. So we're taking the entire region. I don't have a good color. There we go. Ooh, don't like that at all. No. Okay. We took the whole region. So it was like a sheet of paper. And we revolved the whole region about the y-axis, the x-axis, the whole region about the x-axis. And we got that. Okay, any questions? Any questions?
Why did
I got a question real quick.
Yes.
So I see that you shaded in like the region around the top half of the disc, the area. Why'd you shade that one in again?
Okay, so it's like
Why
this.
did he look so high? Aren't the prototype?
Okay. This is the region. So the region is a solid sheet of paper. And what I did was I took this sheet of paper and I made it go all the way around at every angle. There's also the sheet of paper. So when I revolve this thing all the way around, I get a solid because this is filled in. So every time I revolve this thing all the way around, you ever been to a birthday party and they have those little pumpkins or something and they start out flat and then you bring them all the way around, you open them up and they're flat. And then when you open the thing up, you got a three-dimensional pumpkin or whatever it is. That's what this is. So this is different than the first problem. The first problem, this is the base and I stack squares on it. So this is a paperweight and I stack squares on it and it's square, it's got square blocks on the top. The second problem, I have this as a picture on the XY plane. And then I rotate it all the way around the XY plane to make something that is solid, completely filled in. So that's what why I shaded that region. This whole thing is solid. And then I choose an X. And then when I choose an X, I rotate it and I get a disc. And that disc goes all the way around for every piece. So every time I rotate it, I get a disc. I hope that helps.
Oh, okay, yeah, that helps. Thank you.
Okay. All right, ladies and gentlemen, I will see you tomorrow when we finish up. We're going to do washers and probably start cylindrical shells. Okay, thank you.
Dr. Locke.
Hang on, let me stop this.